Hi, everyone. I would like to go over Module 5, discussion question. I read through all of your work, and because this is an introductory material into what's coming next, there was a lot of confusion, and that's to be expected. So I just wanted to let you know, don't feel too bad if you were confused about how to do some things. I kind of expected that, and I just wanted you to engage in the problem and do the best you could with it and figure out what was going on, read each other's work, and reply to that and learn from each other. One thing I would like to say about the discussion post, y'all are doing a really great job. I would just say that if you know somebody has something wrong, or you're very sure somebody has something wrong, you can go ahead and tell them, help them out, tell them in a nice way, but don't just say great work when you know that the work they have there isn't quite correct. So anyway, we have this situation set up where we have this article I read that claimed that according to the growth patterns from 2010 to 2017, the US sales for In-N-Out Burger will exceed sales for McDonald's by the year 21-25. So I actually read this in a business magazine. So I thought to myself, well, that's a pretty bold claim. And I really can't believe that. So I went and did some investigation. I wanted to see what numbers they were using and what kind of claims they were making. And so the first thing I found out was that they said that US sales of McDonald's increased by approximately $0.558 billion each year. So, and I also know that in 2017, I have for McDonald's a total of $37.4807 billion in US sales for McDonald's. So when I look at that, I'm like, okay, well, this sounds very similar to all of Unit 1. I'm given a reference point. I'm told that in 2017, I have this much money. And I'm also told that I'm increasing by this much money every year. So for those of you who noticed that this was indeed a linear relationship, that you just needed to add that 0.558 billion in each year, that's great. And so if we look at Desmos, I'm going to pull up Desmos here in a minute and see what the table should be. So 37.4807. So let me go find Desmos. And that's right here. So I take that 37.4807, and since I know that I'm increasing by a particular dollar amount, 0.558, I just add that. Let me check my number, make sure that's the right number, 37.4807. Yep, 37.407 gives me, add the 0.558, which is my increase each year. And I end up with 38.0387 for year 8. So in 2018, according to this model, McDonald's would have had total sales of 38.0387 billion each year. Notice here I'm adding dollars to dollars. This 37.4807 is billion dollars, and this 0.558 is billion dollars. The units are the same, so I can add them together. Then to find out what the next output would be for 2019, I would just take the output for 2018 and again add that 0.558, and I would get this. And then one more time, 38.5967, add 0.558, and so then this is for 2018, 2019, 2020. Let's see how far the table went. 17, 18, 19, 20. That's as far as I asked you to go. So now you can see if I wanted to input that into a table over here, just so we could, see that. I'm going to go ahead and put a table in here, and I have 37.4807. Then I have 8, 9, 10, and that's 38.0387 and 38.5967 and 39.1547. So now this is the table that matches the table for the discussion board. Now, the part 3 of this discussion post asks you to find what is the rate of change of this data. And rate of change is always defined as the change in the outputs over the change in the inputs. So in order to find the rate of change, I take this 38.0387, I subtract from that 37.4807, that's my change in my outputs, and I divide that by the change in my inputs, which is 8 minus 7, which a lot of you noticed that the input was increasing by 1 year, every 1 year. That made this problem a little bit more easy to work with, because since my inputs were increasing by 1, I only needed to figure out what my output would be for that 1 year increase. And in the McDonald's case, you were told that your increase would be the 0.558 billion. And sure enough, I'm finding here that my rate of change between year 8 and year 7, or between 2018 and 2017, is 0.558. I can do that again if I want to. I can say, okay, let me take this number here. And I'm going to subtract from that the 38.0387. And you're noticing that, of course, you're getting the 0.558 because that's what we added on. That's what we just did. So I would expect to get that 0.558. And if I did that again for the next set of outputs here, I'll just do it. And I subtract the output that came before that. So I take the change in my outputs, divide that by the change in my inputs. And again, of course, I get this 0.558. And so I see that my rate of change is a constant rate of change. And that's because I'm adding that same exact amount on. And so therefore, this function for the McDonald's growth is being represented by a linear function because I have a constant rate of change. When I find the change in the outputs over the change in the inputs, no matter where I do that on my table, I always get this 0.558, which means I have a constant rate of change. Okay, that takes care of the first table. It takes care of question 2 and question 3 for that McDonald's table.